Alright, I probably will collect these, so what I want you to do, make sure you're following along, copying down everything. We're just going to go over the worksheet, but I'm going to move very quickly. So make sure you understand each problem. Everybody should be answering questions, knowing how to set them up. Again, a test on Monday over this chapter. What's that tell us about this triangle? Isosceles. If this triangle is isosceles, those two sides are congruent. What are those two sides called again? Legs. The two angles across from them also must be what? Congruent. So what do you know, or what are those angles called?
Base angles.
Base angles. So we know that they're congruent. That's 40. This is 2x. This problem, I know there's one like this on the test and everybody misses it all the time. If you just told me these two angles are congruent, this one's 2x, what's that one? 2x. So put it in there that way. Put it in there as soon as you know that. Now what? Two x plus 2x plus 40 equals 180. Now what? Divide by 4. Doesn't hurt to come out here and do the division. What's x equal? 35. What'd they ask us to find? Just x? So do we have to go back and plug in? Number 2. Those two angles are congruent. Tell me something else you know in this triangle. The sides across from them have to be congruent, right? Again, remember, if these were the two theorems that we learned last time. If you got a triangle, two sides are congruent, then you know what? The angles are congruent. And the other theorem we learned was if two angles in a triangle are congruent, then what's true? The opposite sides are congruent. It's going to be real helpful on a whole bunch of triangles. So that over here is 3x minus 6. This doesn't have anything to do with the problem, but somebody tell me what that angle right there is called in that triangle. The vertex angle, good. What's this side called?
Base.
The base. Let's see, what equation can we set up here?
2x plus 6 equals 3x minus 6.
How do I solve that?
Subtract 2x.
Get all the x's on one side, good.
Add 6.
What's that? X. Add 6. X equals what?
12.
What they ask us to find on that one? Just x, so that's it. Make sure make sure you're filling all these in. I'm going to erase them as soon as I get done. And then you won't have a chance to write them down. Number 3. We haven't talked about this yet, but anybody have any idea what kind of triangle that is? It's got a special name.
Right. No. Do we know it?
No, I said we hadn't talked about it yet. It's isosceles.
Isosceles, right. You know what?
Exactly. This triangle, how creative math people are. This triangle, what's the two names it could be called? Could be called an isosceles triangle. It could be called a right triangle. Guess what it's called in? An isosceles right triangle. In an isosceles right triangle, I'm going to tell you this just now, and we'll set up another equation here in a minute. But if you have an isosceles right triangle, anybody tell me what the measure of that angle right there is? What do you know about the two angles?
90 and 30 and 30.
Each one is 45, because if you know this one's 90, these other two have to be 45 each. In every isosceles right triangle, it's going to end up being 45-degree angle, 45-degree angle, and a 90-degree angle. What else did they tell us on this one? 3x. I'm not gonna have to move you,
No, I just banged my head, so it really hurt.
so I'm sorry that your head hurts. But can we set up an equation just from that right there? What?
90 plus 3x plus 3x.
All right, you guys are going the long way, so we could say this angle's 3x because they have to be congruent, right?
Plus 6x.
So 90 plus 3x plus 3x
Equals 180.
equals 180.
And then you can
Now, before we go, you solve that, you find x, that's fine, it'll give you the correct answer. Looking down here, if you know it's an isosceles right triangle, is there a shorter equation? What do you know that each of these two angles have to equal?
You can take 45
So what could you just set up?
Divide by 45 divided by 3.
3x equals 45. What's x equal then?
15.
Now, if that didn't make any sense to you, could you solve this equation right here and find x? Yeah, go right ahead. Guess what it's going to give you? X equals 15. Number 4. Number 4, we know that this angle right here is 6x plus 6. We know that this angle is 2x. What kind of triangle is this one over here? Isosceles. So what do you know about those two angles? They're congruent. So if this one down here is 6x plus 6, what's that one up there? 6x plus 6. What's something else you know in this?
Vertical angles, so the other one's 2x.
So this one over here has to be 2x. Do we even need this triangle over here then? What's the equation we can set up?
6x plus 6 plus 6x plus 6 plus 2x equals 180.
Now, where most of you or most of the students get themselves in trouble, did they ask you to find that angle? No. So most people just say, well, I can't do anything because I don't know all three angles. Sometimes you got to find stuff that you don't actually need for the answer, but it helps get you to the answer.
So then that adds up to 14x plus 12 equals 180. I'm sitting here.
You don't want me to take your bag away, do you? Whosever bag it is.
Okay.
You might want to zip it up so that I can go on. Now what?
Minus 12.
Wasting a lot of time.
And then 14x equals 168. And then divide that by 14, so x equals 12.
X equals what?
12.
Everybody agree with that? You better hurry up because you shouldn't have been reaching in that bag and the other bag.
Okay.
You were in my way. I could not see.
Oh, please.
Oh, I swear. Why do you think I didn't get the X
Oh,
plus 15?
We just came from gym class. We are thirsty.
So you're allowed to drink water,
I know she can't water.
so get the water out.
Okay, I'm good.
Hot water's in there, so.
Number 5. Lots of different ways you could do this. We're trying to find x. Somebody, let's just number these angles. 1, 2, 3, 4, Tell me which angle you want to find first. Go ahead, Shreese. 2. How'd you find that?
It's
Wait, how I found it? Well, the two, like, the line up top and the line up there, they're parallel. On the paper, they're parallel.
They don't tell us that.
But they can be.
okay. I
No, they
gotta
don't.
I gotta make
So
a
that angle is 3x. Because it's something.
Or that triangle is equilateral, and since it has that one saying that it's the same, step 4 is congruent to 2, and you know it's an equilateral, 4 has to equal 3x because they all equal the same measure, which makes 2 equal 3x.
All right. So what she's saying, this triangle's not. It's not equilateral, but it's what?
Oh.
Isosceles. And if this is 3x, what's this over here got to be? So we could write that in there. Well, if that one's 3x, what those arcs tell us?
3x, they're the same congruent.
Now what can we do?
One's 90, because that's the 30 plus 90 plus 3x.
All right. So 30.
That's what I had though.
I believe you. You were just not telling me the way that you got
It was
started.
right though.
Equals 3x, or plus 3x equals 9, or, you just got me all messed up. Equals 180, right?
And
Tell
then
me
you
the
can
wrong stuff.
minus 120.
So 120
Equals 3x equals 6.
plus 3x equals 180 minus 120.
3x equals 16. Divided by 3 equals 20. X equals 20.
Number 6. What else we know in this triangle?
That the base angles have to be congruent, so the other one is x.
So if this one's x, this one down here has to be x. What equation can we set up?
3x plus x plus x equals 180.
3x plus x plus x has to equal 180. How many x's you got there?
5,
5x equals 180. Pen's messing up. Divide by 5, what's x equal?
36. Man, I killed this today.
Problem number 7. Problem 7, I'm not going to draw or write all the given and stuff, so you guys got your papers out there, you can help me. Just draw the picture here. How many triangles in this picture? 2. And we're going to split them up. Something like that. Please remember on these 2-column proofs that you're going to have on the test on Monday, about 10 of them. It's a real short test, only like 15 questions on the test, but on these, first thing you do, look at what you're trying to prove. What are we trying to prove here? As soon as you're trying to prove 2 segments are congruent, what do you know that somewhere in your proof you're going to use? You know that that's going to be the very last reason in your 2-column proof, right? If you're proving segments or angles, then you know you got to prove the triangles, then go that step farther to corresponding parts of congruent triangles must be congruent. So we're probably going to try to prove these 2 triangles congruent, so I don't have to keep looking back at this paper. Help me out with the given. What's the first given say? Is that a pair of sides in our 2 triangles? Yeah, so we got a pair of sides.
And then angle A is congruent to angle C.
So that's this angle congruent to this angle. That's a pair of angles, right?
And then.
Is that enough?
No.
No, we got a pair of sides, pair of angles. How many parts you need to prove 2 triangles congruent? 3 parts. Remember your ways to prove 2 triangles congruent: side, 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 angle, side, angle, side, angle, 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 side. Those are the 4 ways. You also have like hypotenuse, leg, all that. Does hypotenuse, leg, or leg, or any of that stuff that we covered last time fit here? What kind of triangles do you have to have? right triangles, okay? And we don't have right triangles, so we don't even worry about those. And I wouldn't be worried about those for the test.
Okay, and then, segment BD, or, I mean, DB, bisect, ABC.
I take a cow to the butcher. They ship me back all my stuff, all my meat, right? And I get some pork, some poultry, some lamb.
For your cow?
You don't, do you? When you bisect an angle, what do you get back?
Two congruent
Angles, right? If you split up an angle, then you get congruent angles. If you split up a segment, you get congruent segments. When you bisect something, when you take something apart, you get the same things back, only smaller ones. So what two angles here are congruent?
angle B,
This is the angle that's being bisected.
angle B,
Nah, we can't name it that way.
angle B, or ABD,
ABD has to be congruent to which angle? That's this angle right here.
CBD,
Angle CBD. And
and,
we knew that because it was being bisected, right?
and angle ADB.
So that was a pair of angles. Do we have enough to say the two triangles are congruent?
Yeah.
Yeah, by what?
ASA.
Angle, side, angle. So Charisse, what other information do we know that's really unnecessary in this one? How do you know that segment DB is congruent to segment DB? Reflexive property. Anything equals itself, right? Did we need it for this problem?
Nope.
No. So it's just sort of unnecessary. Another problem, might you need it? Yeah. And that's one of those things that if you run out of given, that you can come up with. Well, we never ran out of given. We had enough information just from the given to come up with the two triangles are congruent. Once the two triangles are congruent, what are we going to say?
CPC.
We're going to use CPCTC. Tell me what the first statement's going to be.
Segment AB is congruent to segment CB. Given.
That was given.
Let me skip to the next one.
That was the side, right?
Side.
Now what?
Angle A is congruent to angle C.
Is it all right to name those two angles with just one letter?
Yeah.
Yeah. The other angles that we got to name, is it all right?
Oh.
No. How'd you know those two?
Given. And then you can go to.
That was a pair of angles.
The next given, a segment B, or I mean DB bisects angle ABC. And that's also given.
Did I put an S or an A out here beside that?
That you don't know yet.
No, that wasn't saying anything was congruent, but that led us to what were congruent?
That angle ABD is congruent to CBD, and then,
Angle, right?
yeah,
This angle was congruent to that one because the whole thing was being bisected, split into two equal parts.
to CBD.
How do we know that?
When bisecting, if something bisects something, it splits into two congruent angles.
All right, if angle bisected, then split into two congruent angles. That was a pair of angles, right? Is that enough to say the two triangles are congruent?
Yeah.
Yeah. Now you gotta be careful here. Some of them, you have to match up the triangles yourself. Some of them, they match them up for you because it's what you're trying to prove. This time, we gotta match them up ourselves. Name the triangle on the left.
ABD.
ABD. Now you gotta be careful. What do you gotta do to that triangle to get it to match up to the other one? You gotta just flip it over, right? So what's the A match up to?
C.
C, what's the B match up to?
B.
And what's the D match up to? Now be careful here. Remember, what's the only four things that can go as a reason when you put two triangles over here?
SSS, ASS, ASA, AAS.
if you write anything else over here, number one, it'll probably make me cry. Number two, I'm probably gonna write something nasty on your paper and say, it's got to be one of these four things. Now, you won't be able to read me yelling at you on the paper, right, Chloe? But I'm gonna put a bunch of exclamation marks on there to show it like I'm yelling. All caps.
Your reason for this is ASA.
Angle, side, angle this time. How come it's not angle, angle, side like it says over here?
Because it's not the way it's in order.
All right, remember back over here? Included side between the two angles, that means angle, side, angle. Are we finished?
No.
Now what?
Segment AD is congruent to segment CD. And the reason for that is CPCTC.
What's that mean again?
Corresponding parts of congruent triangle sides, something C. I don't know.
Congruent triangles are congruent.
Must be congruent.
Sides.
12 points on the test. How many of these should you for sure get?
All the givens and the CPCTC.
So you got, count them all up for me. How many total points?
1, 2, 3, 4, 5, 6,
4.
7, 8. You should get 10.
8. Should you get this one? Should you be able to match up the triangles?
Yeah.
9, 10. You can't get 10 out of 12 on that.
Honestly, on this one, I think you should be able to get all of them.
I think you should be able to.
But just
You should be able to get at least 10 out of 12. Maybe, let's even go this route. Maybe even just 9 because maybe you guessed wrong there. Like if you put segment BD is congruent to segment BD in there, instead of angle, side, angle, you might think it's side, angle, side. And could it have been side, angle, side? Yeah. If you left out that angle, which was one of the given.
Wait, so with that single out.
So there's other ways. So there's other ways you could have proved that.
Would it still be right? Yeah, so you can have, that's what I was wondering too.
It would still be right, but you got to make sure that you put in the right parts. Because if we go with side, angle, side, then we would leave out this given. Well, if we leave out that given, that takes 2 points away that you're not getting. You're adding points, but you're taking away points. Yeah, you would. You wouldn't need these two angles
so
because we'd go side, angle, side,
can we turn this into you and have you give us a grade on it?
maybe.
Because we were all pretty
Yeah, not too bad.
good today.
All right, if you put your names on them, Katie will come around and collect them. The rest of you have your books open to page 219. 219. Some of you had already started this. Go back and check your answers. We'll go over problems off of 219 here in just a minute. So check them, see which one you have questions on.
32.
And then we will go over some of them. Katie, when you get them, just lay them right here for me, please. When I teach, right? Right.
Do you teach? Is that what you're asking?
Lauren doesn't usually pay attention anyway, so I don't know that it mattered that Mrs. Evans did or didn't. Yeah, that's what I was asking. I teach, right?
She watches
Yeah.
this video, she's wondering.
You're like, I'm not.
That's what they were supposed to do was watch the video.
I'm not complaining at all, but like, you definitely teach. You'll go over a problem, do the same exact kind of problem that's like the same exact answer basically. So I mean that's good because then it gets stuck in our brains. But yeah, you teach.
A lot of the people don't. All right, on page 219.
For the heck of it, I will have you do problem 16. No, I'll have you do problem 24.
24. Problem 24. Be ready to ask other questions. Problems you want to see worked. Uh, 24. Please tell me if I draw a picture wrong because they got pictures that sort of look the same and I label them wrong. write one above the other and stuff. Problem 24 says JM, and don't go by my picture, is congruent to PM, because those two for sure don't look like they're congruent. What kind of triangle is JPM then? Isosceles. Which two angles have to be the same?
The two base angles, J and P.
Alright, now you can't really name it angle P, but we'll go with it this time. So those two angles have to be congruent. Then they tell us ML is congruent to PL. So which two angles there have to be congruent?
M and P, which you can't really name it then.
Yeah, you can't name that, but we'll go with that for this time. I know what you're talking about. So we have that, and they tell us, let's see, you said 24, right?
Yeah, P, L, J.
PLJ, that's this angle,
So the whole thing, 56.
58.
L 58. And glasses.
Now let's just go through and I don't even care what angle they're asking us to find. Let's just find every angle that we can find in this picture. If I split off that triangle on that side, and that's 58, how can I find these other two angles? Good, 180 minus 58.
Divided by 2.
Let's do this real quick. I have to borrow there. 122. Then divide that by 2. What's 122 divided by 2?
61. Oh, that's 61.
61. So that angle's 61, that angle's 61. Let's write them in here.
Wait, how do you get 58?
They told us.
Oh.
What could we do next?
61 plus 61 plus 58.
Tell that like 58 corresponds, I think, to J. Well, L corresponds to J.
Oh.
In a way.
Are these two triangles congruent?
No.
No, but wouldn't like angle PML be congruent to PMJ? Like, cause they're like
These two would be congruent?
adjacent. Oh, they're linear pair.
They're a linear pair, so what do you know about those two?
They're the same. So this.
Nah, they're the same.
Congruent.
61.
They have to add up to
Oh yeah.
180. That's what being a linear pair means, right?
How much is it?
What's that give us?
119.
119?
I think.
Is that right?
Yeah.
So this angle right here is how much?
119.
119? How would we find these other two angles in that other?
You would take
Triangle.
180 minus 119 and then divide that by 2.
180 minus 119. Well, we just did that, didn't we? 61. Do what with that?
Divided by 2, which would be 30.5.
So this angle is 30.5 degrees, and that angle up there is
Oh, this stuff's
35.
easy. Okay.
Now again, I think they were asking you to find that angle right there, 30.5, right?
Mhm.
Could you jump straight from this being 58 to this being 30.5 and not find this other stuff? No, you have to go through, even though what you guys have gotten used to in math classes all the time is just finding that one direct answer, right? Well, sometimes you gotta find other things before you can get to the answer that you want. So you gotta be able to do that. Other questions?
32.
32.
I messed up on it.
Problem 32.
Oh. We did 32?
Or 36.
36.
Okay.
I was gonna say.
I was
Yeah.
confused for a second also.
Sorry.
That's
I
right.
did too when I looked up the thing 32. I was like, never mind.
36, what kind of triangle is this?
That's oscillates.
If this angle right here is 3x plus 8,
The one across from it has to be the same.
this one over here, these two have to be congruent, so it's got to be 3x plus 8. And then this one down here is
2x plus 20.
2x plus 20.
So couldn't you just do 6x plus 16 to like save some space?
What do you know about all three angles in a triangle?
They have to 180.
So how many x's do we have? Let's do that.
8x
8x
plus 36.
plus 36. All that add together, this plus this should equal how much?
180.
Now, be careful on the test. It's a problem like this on the test. What equation can you set up there?
It equals 180.
Oh,
Because you don't know how much.
You might set two of them equal to each other.
Set the two sides, never mind. Yeah. and then
Maybe. But
except
what
the
do you
x-
make sure you do not do?
Equals 180.
They do not add up to equal 180. The sides of a triangle do not add up to be 180. The three angles of a triangle add up to be 180. So make sure you don't make that mistake. Subtract 36.
144.
Then what?
Divided by 8.
What's x equal? What'd they ask us to find on 36 so I don't have to look back at my book? They asked us find the angle or did they x or what?
It's just like x.
Just find x, so that's it? They didn't want us to plug back in? Other questions?
Will any problems like this be like on our test?
If we had a test over what we just did, like not just at the Alderman, I feel pretty confident.
Everything we've done this chapter has basically been the same thing over and over again, right? I
It's
mean, at
like-
first we start off knowing that three angles of a triangle add up to be what? 180. Are we still using that? Yeah. We just added a little bit to it, like the isosceles and equilateral.
Wait, what is the only way you make a mistake, like with the sides and then the angles? Because doesn't, if it was the angles, it'd have a little degree sign. If it wasn't, it would just be set
Yeah.
like that, right?
Unless, because you notice when I write it up here,
You're on the inside.
sometimes I try to write it on the inside. Do I always put the degree symbol?
I guess I haven't really noticed.
Sometimes the book does and sometimes they don't.
I just figured you always, I don't know, I don't think I've messed up like between those two. Anything, I just don't
I mean, I try to if I remember, but other times I don't remember. But you should be able to, if I put it like this, you know that that's pointing at supposedly the angle down there, right? Not the side. So yeah. If it's like this, if it's written right towards the middle of the segment, then you know it's dealing with the segment, the side. Other questions? All right, go ahead and start copying this down. You probably want to skip space in between each one. We'll write some stuff down with each one. This is what's going to be on your test come Monday. All right, again, we're going to write a couple things down for each of these. You write down whatever you want. This is what's going to be on the test. First thing we covered in this chapter, be able to classify triangles according to the sides. I am going to, just write down 3 names. What were the 3 names that you can name a triangle according to its sides? Scalene, what's scalene mean?
No sides.
No sides congruent? What next? Isosceles. What's isosceles mean? 2 sides congruent, and then what's the last one? Equilateral. Guarantee there's 2 or 3 questions on there ask you to classify triangles, name the triangles. What's equilateral mean? All sides congruent. Now we had 4 names for if you're classifying or naming the triangles by the angles. One was, let's start with the acute. What's acute mean?
One angle is less than.
One angle?
No.
All angles are less than 90. Next one, obtuse. What's that mean? One angle is more than 90. Not all the angles, but one angle is more than 90. Next one, right? What's that mean? Has one angle that's 90 degrees, and then the last one? Equal angular. What's that mean? All angles are equal. If a triangle is equal angular, what else do you know about it? It's equilateral, and you might want to draw this picture. If you know a triangle is equilateral, all three sides are the same. Tell me what you know about all three angles.
They add up to 60. Well, each angle is 60.
Each angle is 60 degrees. Make sure you remember that. 180 degrees. Why was that important in this chapter?
That's what all triangles add up to.
Three angles of triangle always add up to 180. This is the theorem that a lot of people forget by the time we get to the end of the chapter, but it's helpful some of the times. Which angle is an exterior angle? 4. All right, 4 is an exterior angle. Which two are the remote interior angles? 2 and 1. Remember, it's the two angles on the inside of the triangle that are away from the exterior angle. And you know that angle 1 plus angle 2 has to equal angle 4. The two remote interior angles have to add up to equal the exterior angle. Next one, what are these used for?
Proving triangles.
That's all they're used for, and that's the only way that you can prove two triangles are congruent. Now, why did I put the etc. on there? What else could you use? The right triangle, HL, LL, stuff like that. I didn't put it on there because I really don't want to confuse you. Anything on the test, you should be able to prove the triangle is congruent by one of those four things. Maybe you could use HL, but you don't have to. Or LL, or what was the other one? HA, or LA, or no, LH. Was LA one of them? Yeah, LA was one of them. Where do you, what's this stand for?
Corresponding parts of congruent triangles are congruent.
Again, don't make this harder than it is. You got these two triangles, and we figure out that they're congruent to each other. We lay them over top of each other so that we can see which parts correspond with each other. So we now know that this angle corresponds to that angle, right? Well, those two corresponding angles have to be congruent. When do you use this?
Proving angles or segments.
All right, when you're proving two angles or two segments, if that's your proof, and you only use after you've proven triangles are congruent. That's the only time you can use it. You can't just put CP, CTC in a two-column proof anywhere. It's got to be after you prove the two triangles are congruent. For isosceles triangles, make sure you remember these two theorems. If those sides are congruent, then what do you know?
Then the base angles are congruent.
Then those two angles have to be congruent. Does that shortened form confuse everybody? Should I write it out?
Yeah.
So, if sides, then the opposite angles. What's the converse of that say?
If base angles are congruent, then the legs are congruent.
Alright, so if you know those two angles are congruent, then you know the sides opposite them have to be congruent. In an isosceles triangle, make sure you remember the parts. What's this angle called in an isosceles triangle?
Vertex angle.
Vertex angle. How about these two bottom angles? Base angles. How about this bottom side? Base, and the other two sides?
Legs.
Legs. Make sure you know those parts, because whenever they tell you a triangle is isosceles, they have to tell you something else. They can't just say triangle ABC is isosceles? Because if they tell you just that, which two sides are congruent? That's the ones most of you would guess. Did they tell you that? Do you know which two sides for sure are congruent? So they'd have to tell you something else. A lot of times they'll say triangle ABC is isosceles with vertex angle A or vertex angle B. And they'll tell you one of the parts so you know where the legs are and where the base is. And that's what they got to do. Equilateral triangle. If a triangle is equilateral, what else you know about it? All the sides are congruent and all the angles are congruent, so it's also equiangular. And you know that every angle is 60 degrees, so on, so on, so on. That's all right. We're about ready to get them all in. All right, what we're going to do, open up your books to page. We got about 18 minutes or so, no, 20 minutes. Wow, that's a lot of time. Maybe we should waste a little time.
No.
Yeah.
Open up your books to page 227. Get out a sheet of paper. What we are going to do while you're doing that, I'll explain. I'm going to have, and it doesn't matter who does it, somebody will come up to the front, or not to the front, to my desk. They will grab a number out of this bag. You're going to work that problem out from page 227, 228, 229, so on and so on the board as a class. Make sure you got the right answer. Then you're going to say, okay, Mr. Eversole, we're ready for you to check it. If it's right, then I'm going to let somebody else come up, or it could be the same person. I really don't care.
I volunteer as tribute, guys.
And draw a problem out of this bag. You're going to write that problem on the board, and everybody should be writing it down. This problem, the problems in this bag are the problems that are on the test come Monday. These are the exact test problems. Everybody understand that? So you're going to draw a problem out of here, write it on the board. I will not help you in any way, shape, or form. You write it up there. You can work it out together. You can write it up there and just say, okay, here's the problem. All of you are on your own to try to figure it out. I don't care. All right? But I will not help you with it. Does everybody understand all that?
Yeah, guys, I volunteer as tribute.
No. Doesn't matter who draws the stuff. All right, so somebody come up and draw a number out of this bag for me. Problem 20. Oh, she drew a 2-column proof right off the bat.
Are you serious?
Problem 20.
On what page? 229. Wait, is this problem 20 on what in the homework?
Well, it's not homework, it's what we're doing.
No, in the homework, it's number 20.
No, it's problem 20 on page 229.
Or 229?